Hi everyone! Today we'll be working with the function f of x equals 2x cubed minus 24x squared minus 6x plus 5. By using the power rule, we can figure out the derivative. F prime of x equals 6x squared minus 48x minus 6. We can use the power rule again to figure out the second derivative. F double prime of x equals 12x minus 48. We can use the second derivative in order to find the intervals on which this function is concave up and concave down. Our first step is to figure out the possible points of inflection by setting f double prime of x to 0 and solving. In this case, our possible point of inflection occurs at x equals 4. Now that we know that x equals 4 is a possible point of inflection, we can set up a sign test around this point. We must test a value that is less than 4 within f double prime of x, and another value that is greater than 4. So for the value that is less than 4, we can test x equals 0, and f double prime of 0 is equal to negative 48. The value is not so important as the sign, and we know that 0 minus 48 is negative, so the interval of negative infinity to 4 would get a negative sign. Now we test a value that is greater than 4 in f double prime of x. We can test the value of 10. 12 times 10 is 120, and 120 minus 48 is clearly a positive number, so we can label the interval 4 to positive infinity with a plus sign. Based on the results of our sign test around x equals 4, we can conclude which intervals of this graph are concave up and concave down. The interval negative infinity to 4 is concave down because the sign test concluded that f double prime of x is less than 0. On the other hand, the interval 4 to positive infinity is concave up because the sign test concluded that f double prime of x was greater than 0. The final step is to determine whether the possible point of inflection x equals 4 is an actual point of inflection, and in this case it is, because when x equals 4, the sign of f double prime of x changes.